No, what are you waiting for? I am waiting for your book. Come on, take up. We're not watching the TV there. Take your attendance and pass it along. Are you having any tests this week?
On Sunday.
What? Which one?
Chemistry.
You're having chemistry? First and second, isn't it? How are you prepared with your second one? Second position?
Two chapters, yes. Those chapter chemistry, chapter maths. English का लो English का लो हो गया
Okay, let's see. You have your textbooks with you, notebooks. Did I give you any homework? Homework was there to study, isn't it? You have to study whether you like it or not. That will be homework. Chapter 2, we have almost finished with everything. Then we see a few questions which are given in the exercise, and then we start with the new chapter. Are you okay with that?
Compound is over, no?
Yes, over. Element, compound, physical change, chemical change, everything is over. Do you know what is a physical change and a chemical change?
Yes,
Okay, we'll take up a few examples. The last page of your lesson, and pure substances as well elements and compounds. See, we find many changes happening around us. Okay, but we can make out that some of them are physical changes and some of them are chemical changes. Suppose I take a balloon and blow it up. You can easily identify that it is a physical change. Okay. But suppose we are saying digestion of food. It's a chemical change. So how do we identify what is a physical change in the chemical change?
One physical change is that in which the change can be reverted, and in the chemical change we can take the substance.
Okay, irreversible change. In most of the cases, it is irreversible.
The change in new substances from whereas in physical change in new substances not.
Yes, that is the most important thing. So the point that we have to look at is a new substance is formed. Okay, here there's obviously no new substance is formed. Yes, sir. Correct? Maybe understand this. This is the most important part of it. Okay, of course, it is a reversible change. It is an irreversible change, and so on and so forth. So when you look at page number 19, if you look at your textbook page number 19, hey, you don't have a textbook. I never find you with your textbook. Why is that you don't want to get your textbook?
NCERT.
Exactly. This is
All
all exactly. I know you have at least one. Is that the reason why you don't bring, so that you will both share and all that? Okay. Suppose I'm saying I'm boiling water. What type of a change is it?
Physical.
Physical change, physical change.
Physical.
Okay, let us see. Let us say I have water which is at 30 degrees and I'm heating it up and it will start boiling at 100 degrees Celsius. Boiling now.
Chemical.
Why do you think it is a physical change?
Because it is reversible. Condensation.
What else do you feel it is?
Reversible condensation.
And
What
no
do
new
you think?
substance is formed.
Is there a new substance formed?
And water makes a new substance.
What is the formula for water?
H2O.
H2O. Okay. So it has got 2 atoms of hydrogen, 1 atom of oxygen. What is steam? Steam or vapor? It is water vapor. Correct? So it is water vapor. What will be the formula for water vapor? H2O. Only thing is there is a change of state. This liquid has become a gaseous state. That's all. Okay, this is also H2O. Okay, no discussion now. Okay. If you understand, the formula remains the same. It is not a new substance which is formed. So what type of a change is it? It is a physical change. Same thing. Suppose I have got ice, which is in a solid state. It is getting converted into liquid. So it is a physical change. Did you understand? In a physical change, no new substance is formed. And therefore, we can say that it is a physical change. Did you understand? Let us say ripening of fruits.
Chemical.
You should remember that it is a okay.
But how is that a chemical change?
See, when you're taking a fruit, there's a change in taste, there's a taste change in texture, okay, color. So obviously new chemicals are being formed. It becomes sweeter. Okay, kacha thing is sour. And it becomes a fruit, a ripe fruit, obviously it is sweeter. So fructose is being formed. So therefore, see this paragraph? Yes. Are you ready with this page? Page number 19.
The interconversion of states is a physical change because of these changes occur without a change in composition and no change in the chemical nature of the substance.
I want you to underline these words. There is no new substance, okay? There is no new, no chemical change.
Although ice, water and water vapor all look different and display different physical properties, they are chemically the same.
Correct? Did you understand? They're all chemically the same because the chemical composition has not changed. It's only a different physical form. Yes.
Both water and coconut oil are liquid, but their chemical characteristics are different. They differ in odor and inflammability. We know that oil burns in air, whereas water extinguishes fire. It is this chemical property of oil that makes it different from water. Burning is a chemical change. During this process, substance reacts with another to undergo a change in chemical composition. Chemical change brings change in the chemical properties of matter, and we get new substances. A chemical change is also called a chemical reaction.
Okay, it's a chemical reaction. Now I'm asking you another question. Suppose I take water, okay, and I pass current, electric current, and it is breaking up into, let us say, hydrogen and oxygen. See, hydrogen is there, oxygen is there. So I've got two elements from it. Now tell me, is it a physical change or a chemical change? Did you understand? Because there's a new substance. These are all new things which are formed. Did you see? Okay, so therefore, such a type of a reaction is basically what is known as a chemical reaction or a chemical change. Obviously, it is not balanced, so we have to balance it by putting the right. Okay. Yes, come on.
During burning of candle, both physical and chemical changes take place. Can you distinguish these?
Chemical change.
Tell me what is happening when the wick is burning.
Melting of wax.
Yes, melting is just melting. You know, the solid is becoming a liquid state. That is a physical change. But when it is, when flame is there, that means it's burning. It is obviously burning with oxygen, and it forms carbon dioxide and water. So that is not being seen, of course, but that is a chemical change. Okay. So where there are some small questions here, it's very easy. Then you make out cutting of trees, melting of butter, rusting of almond. What is rusting of almond? Rusting is
that white thing,
reddish.
This is a chemical.
It's a chemical change because basically we are obviously talking about an iron. Obviously, because they are talking about when they want a chemical change, rust is formed. Okay, suppose you have an almara which has not been painted, or the paint is peeling off, it's an old almara, obviously rust will go back. Boiling of water to form steam, physical. Now, passing electric current through water and water changing down. See, this is what
cutting of trees physical hoga na?
Yeah, physical. No new substance.
And melting of butter in a pan also physical.
Melting, just melting. But if you heat it for a very long time, then of course there are some chemical change will take place. Yeah, because melting, when you are actually melting and when the butter starts boiling, it becomes into ghee, so obviously there's some changes which are made. But if they just write melting, it is just. Okay. Dissolving common salt in water. Dissolving. What new substance is formed?
Salt and water.
Salt, water. That's all. No new substance is formed. It's a physical change. Can you separate out salt and water?
Yes, ma'am.
Yeah, by process of evaporation. So it is a physical change. Okay. Then fruit salad with raw fruits.
And burning of paper and wood.
Cutting the fruits and making fruit salad. Physically. Burning paper. Yes, correct. Wood burning is also. Okay, fine. So you are okay with that? Did you understand what is a physical change and a chemical change? So we know that this is basically. Now the next part of it, I'm sure you are okay with it. We're talking about pure substances. What is a pure substance? What are the two types of pure substances? Element and compound. What is an element?
Element is single
molecule of something.
Single molecule.
single substance. Like substance.
We're talking about pure substance. Element is definitely a substance.
Single atom.
नहीं single atom नहीं. I mean, कोई एक से
Correct, you are right. But how will you put it out?
nitrogen or oxygen.
What is an element?
It is a pure substance which cannot be broken down into simpler substance.
It is a pure substance. This is a, yeah, it is a pure substance. Okay, atoms of a pure substance, atoms of an element, one of them will remain the same.
An example, carbon.
Carbon, sulfur, iron, aluminium, all of them are elements. Okay, so atoms of an element, one of them will be the same. What is a compound as a compound? One minute, don't scream. Ah, yes.
Compound is a substance composed of more than one or two
Two or more
elements.
How are they formed?
In fixed ratio.
Yes, it is important.
Fixed proportion.
Simple thing, HCl, H2SO4, H2O. Okay, that is okay. So those are the examples. So when you talk about a compound, it may have two or it may have more than two. Here there are only two, hydrogen and oxygen. Here hydrogen, sulfur and oxygen. Okay, so elements which are composed, which is present in a fixed proportion. Whereas an element, only one type. Okay, atoms only of one pure substance. And remember that both of them can be classified as pure substances. Mixtures is an entirely different homogeneous mixture, heterogeneous mixture, colloids.
Atoms are elements.
Atoms are present here, atoms are also present here. Atoms are present in every substance. Did you understand? That's the next topic that we are going to discuss.
Mixtures are just like mixing up the compounds and the elements.
Yes. For example, if I say mixture, if I say example of a mixture, and we said milk is a mixture. What does it consist of? Water,
Sugar.
protein, calcium, fat. Did you say water? So it's a mixture of many substances. Did you understand?
Yes, ma'am.
So milk is a mixture. And mixtures we have studied thoroughly. We said it's a homogeneous mixture, heterogeneous mixture. Yeah, tell me.
So, why is water
Water is H2O.
It's a compound.
It's a compound.
Like the water from ocean, like it has a lot of.
That is when I'm saying, okay, now we have to be very clear about the question. Listen. Suppose I say water. I'm just saying water. Okay? If I take water, the chemical nature of water will be the same from the well or from the sea water or from the river water. What did I say? I am talking about the chemical nature. That means the formula will be the same. Okay? But if I collect sea water, it is salty. right? Because there are some other things which are also present in it, potassium chloride, sodium chloride. We're not talking about the chemical nature of water. What is sea water? It is a mixture consisting of water and so many other stuff.
Ma'am, seawater is a compound.
No, it's a mixture.
When you say sea water, why you are getting confused? They are talking about the chemical nature of water. H2O plus, that's all.
And what is a mixture?
Water is not a mixture.
What is a mixture?
What is a mixture? Suppose I put salt, I take water in a glass and I put salt, that becomes a mixture. So your argument,
Water
sorry?
and salt.
Water or sand.
Water and sand, that is okay.
Sorry.
Okay, now I am giving you three things. Now see, okay, I am giving you sand, salt and water.
Mixture.
Now we can separate it.
Precipitation. Filtration.
Sand, so stable. I am giving you sand, salt. It's not there in the text.
Evaporation.
And first we will separate sand by
Wait. One by one.
First we will separate sand with water by filtration, and
What
then
else you get? Follow T step by step.
ma'am,
Sand, salt, and then what did I say?
water.
Okay. Then tell me. By
Then
filtration. Okay.
we'll go burn it so by evaporation, and then we get salt. Both until we condense the water vapor and we get salt, water and sand.
Understood. Did you understand? No. I have three substances. I said I have got, let us say, I have salt, okay, water, and sand. The moment you put water and salt, it becomes salty water. This will dissolve in water. Okay. So sand you can easily separate by filtering. What you are having is only salt water. Salt water you can do evaporation. Hey, you did not sign, who you have to sign?
It's
So Virat, are we clear about it? Your confusion was with sea. If you are saying salt water, we say it is a mixture, but when I am talking about sea water, I am saying it is not a mixture.
So basically, mixtures contain more than one substance,
Substance.
and compound contain more than two elements.
Elements.
They form a new set.
Is it here? Right. Chalo, then. Here. On the same page, page number 19. All this we have already done. Elements, what are the different types of elements? You remember what are the three types of elements? Correct.
Metal, normal, and metalloids.
And metalloids. Okay, and I've given you a
Yes, ma'am.
table also chart. They are elements. Metalloids are elements. This is metal, this is non-metal, and these are metalloids. Metalloids are elements, but having properties of both metal and non-metals.
Alloy be elemental.
Alloy is a mixture of two metals. It is not an element. It is a mixture. Are you clear about it? Now I want you to be thorough with this chart, this table here on page number 18. Okay, so that is telling us about colloids. Okay, it's a mixture. Common examples of colloid. This one did you see? Yeah, correct. Okay. So if gas is present in a liquid, it's called as an aerosol. Okay. Or if it is air, which is the liquid which is present in a gas, foam.
Ma'am, so like steam is also an aerosol.
Yeah, it is a liquid which is present in a gas.
Liquid present in gas and gas present in liquid, both are the same, right?
No. See, what are the two parts of a colloid? It's a dispersed phase and a dispersed medium. Look at the first part in the column.
Yes, please.
Okay, dispersing medium. Dispersing medium is the one which is more, whereas dispersed phase is the one which is small. See the first one itself, you will understand. Fog, okay, or cloud or mist. little amount of liquid. What liquid are we talking about? Water droplets, which is present in gas. So your dispersed phase will be small. The quantity will be small. You remember solute and solvent?
Yes, ma'am.
What is present in large quantities? Solute or solvent?
Solvent.
Solvent. Solvent is present in large quantities. Solute is present in small quantities. So same thing here. Instead of using solute and solvent, we are using dispersed phase and dispersing medium. Here? Okay. 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 Let's look at the questions. Okay. Look at question number 6.
Question number 6. How do you confirm that a colorless liquid given to you is pure water?
Suppose in a beaker somebody gives you clear water, clear liquid. Colorless liquid given to you is pure water.
Ma'am, maybe.
Scatter a beam of light.
Yeah.
So,
I'm 100 degrees Celsius.
It is also.
Boiling.
It is boiling at 100 degrees. A
if
substance.
something is mixed in it, the temperature of boiling and boiling also will change.
So if it is pure, that is why they have given us pure water. Okay, right on the answer. Quickly. Question number 6. Okay, question number 6, I'll give you the answer. Okay, if the colorless liquid boils at 100 degrees Celsius, then we can confirm that the liquid given is pure
If the
water.
colorless liquid
Boils at
then the
colorless liquid boils at 100 degrees, then we can confirm that the liquid is pure water. Okay, we have already discussed this solubility. We have discussed, no?
hang on.
Solubility.
Yeah.
Yeah.
Solubility chart and all that.
Potassium nitrate. Done.
You were absent? Maybe you were absent on that day?
We are not in
Are you sure?
Yes, ma'am.
Okay, let's see. What is solubility? Okay, go behind. We'll run through. Okay, we'll take up this again. Okay, come to page number 16, 17. Solubility. Okay, when do we say it is a dilute solution? When do we say it? We have done now. We have done this also. Example, some.
Yes, ma'am.
Yeah, we have done.
Oh,
Anyway, I will run through. I will explain to you once again. I remember doing that very well. Okay. When we talk about a solution, we know that it consists of solvent and solution. Correct? Solvent is the larger part. Most of the times we are talking about an aqueous solution, so it is water. And solute may be sugar, or we are talking about salt. Okay, so that is your solute. Now, how can we tell what is a dilute solution, what is a concentrated solution? So, solution can be dilute, or it can also be concentrated. What is a dilute solution?
it is
In which the solvent, talk in terms of solute.
Where the solute is less. The amount of solute.
the solute is more.
Okay. Suppose I take a beaker, let us say it has got 100 ml of water. Correct? And I am going to put copper sulfate. Copper sulfate are blue color crystals. And I put a few crystals. And if I put, let us say, 50 grams of crystals, so which will be more? Yeah, obviously 50 grams is concentrated because you put more. So how do you define a dilute solution? In a dilute solution, if you keep on adding a little more of copper sulfate, it will keep on dissolving. Okay, you can keep on putting a little more till it becomes a concentrated solution.
So ma'am,
So how do we define a concentrated solution? Is when it has reached a maximum amount of your solute. You cannot dissolve any more copper sulfate in it.
so ma'am, alcohol का example,
Alcohol. Alcohol wine.
alcohol and water.
No, we are talking about concentrated solutions, which basically in terms of salt or, okay, right? So in terms of salt or sugar or copper sulfate, yes.
When we talk about alcohol, so like we can put as much amount of alcohol we want to put it like.
It is on. We are talking about dissolution of a solute in a solvent. Whereas in alcohol and water, it is a homogeneous. Yeah, did you understand that part? Did you get it? Okay.
Yes, ma'am.
So in a concentrated solution, what is happening? It has already reached its maximum capacity for dissolving. You will not be able to dissolve any more salt in it. Watch it, sit straight. Sit straight. Did you understand? Okay. So come to page number 16, concentration of the solution. Okay. Go to the next column here. So the proportion of solute and solvent can be varied. Varied means what? You can vary. Okay. Depending upon the amount of solute present in the solution, it can be called as dilute. Did you underline? What is dilute? Solution and saturated solution or concentrated solution. Dilute and concentrated are comparative terms. In activity listing, dilute is basically we are talking about that. Okay. Now, what is happening with respect to temperature? What happens if you are having a saturated solution? And what happens if you are increasing your temperature? Let us say you have now taken, see here, look here, look here. You have taken 100 ml of water and you have put copper sulfate, then it becomes a concentrated solution. Okay. Concentrated solution, it has already reached the maximum capacity. If I increase the temperature at this stage, if I'm increasing the temperature, what happens?
The salinity increases.
Correct. You can put a little more of the salt in it. Okay, then it becomes a super saturated solution. So you have got dilute solution, concentrated solutions, and you also have got a super saturated solution. Did you get it? Understood?
Like a super saturated solution, how can I explain this?
Super saturated solution is it has taken the maximum amount by increasing the temperature. So what happens at about 50 degrees, 60 degrees, if you increase the temperature, you can put a little more salt in it, then it becomes super saturated. Now you allow it to cool. When the temperature slowly begins to cool down, you will find beautiful crystals of the excess amount of salt that you have dissolved that is coming out. Okay, it will be formed in the form of crystals. So nice crystals will be formed. Okay. These are the crystals of copper sulfate which you can see. Did you get it? Okay. Take down this.
Then why does this happen?
It doesn't happen. We are talking about different type of concentrations of solution.
No,
Nature.
after heating the water, why does the
Sorry,
salinity
why does the solid variate? Because what is happening when you're increasing the temperature? The kinetic energy also increases. Okay. So it begins to move around. And therefore, these molecules of copper sulfate are able to dissolve much more with the interface. Got it? Come on, write down this. Saturated solution. I'm giving you the definition of a saturated solution.
the one we did right now, right?
That is super saturated. I'm just talking about a concentrated or saturated solution. A solution that has dissolved, a solution that has dissolved as much solute as it is capable of dissolving is called saturated solution.
Concentrated solution is also the same way.
Saturated solution is a better word because that gives you the maximum.
So when like concentrated and saturated are like same.
No, they are not the same. See, if I'm having a dilute solution and if I put a little more, then you say it is a concentrated solution. In a saturated solution, what is that? It has taken the maximum capacity of the solute, so that is saturated. For example, in this room, let us say it can seat 30 children. Okay? If only 2-3 children are sitting, they are dilute. If there are 10 of them are sitting, it is concentrated as when compared to dilute. If 30 of them are sitting, then it is saturated.
So I'm currently in dilution.
Just to give you some idea. Okay, come on now. There is another way you can express this statement. I'm giving you that statement also. Okay. In other words, or you can also write down or another statement I'm giving you. When no more solute can be dissolved, when no more solute can be dissolved in a solution,
When no more solute.
solute can be dissolved in a solution at a given temperature, it is called saturated solution. Okay. A dilute solution can also be called as unsaturated solution. Okay, now you leave a line and write down what is unsaturated solution.
But an unsaturated solution can be both dilute and concentrated. Right?
Because
Concentrated solution is also an unsaturated solution. Yeah.
So it can be both, but
That's why I'm giving you with respect to unsaturated solution. What is an unsaturated? See, concentrated and dilute is just visually also we can record. It's not a very scientific term. So it's better to write as unsaturated.
yeah,
Okay? Unsaturated solution. What is an unsaturated solution? Filter. If the amount of solute contained in a solution contained in a solution
if they want the solute,
contained in a solution is less than the saturation level, is less than the saturation level, it is called an unsaturated solution. All of you look into your textbooks and mark it here. See here. Did you get these two sentences here? Unsaturated, saturated. Somewhere in the middle of the page. Did you get it? It's there. Put a tick mark. Underline it. Put a tick mark. Something. Got it? Okay. What is solubility? We say a salt is soluble. Solubility. What is the solubility? Come on, take it up. The amount. The next definition. What is solubility? Huh? Solubility.
I'm going to
The amount of solute. The amount of solute present in the saturated solution. Amount of solute present in the saturated solution Okay, at this temperature, at a particular temperature, right? At a particular temperature is called its solubility. Solubility, yes.
Get this.
Did you get this? Did you understand what?
Yes, ma'am.
The amount of
Solute contained in a solution is less than the saturated level. Then it is called as, it is, sorry, what did I say? Solute, the amount of solute present in a saturated solution at a particular temperature is called solubility.
Solubility is like something.
I'm giving you an example which is behind that. Is why I'm giving you all this data. Look at question number 3 here. Okay, some student, Pragya, see there, tested the solubility of 3 different substances at different temperatures.
Yeah.
Question number 3. Correct?
Yeah.
Okay, at different temperatures and collected the data. Okay, and the results are given in the following table as grams of solute dissolved in 100 grams of water. So in all the 3 cases, how much of water we have taken? 100 grams of water. So that has not changed. Okay. What are the substances these are? Look at the table and tell me. Potassium nitrate, sodium chloride. Look at your textbook, otherwise you will not understand what I've written. So how many salts have we taken? 4 different salts. Okay. In the second column, what are we talking about? Temperature. We are talking about temperature, which is given in K, Kelvin. Okay. 283, 293, 313, etc., etc. And we'll see what is happening to solubility. Okay. Okay.
Now इन सबको minus करेंगे तो
Minus 2 minus 2 Okay, now look at the questions there. What mass of potassium nitrate will be needed to produce a saturated solution of potassium nitrate in 50 grams of water at 313? Look at the table of 313. How much is it? 62. But 62 is in 100 grams. Now what are they asking in the question?
50 grams.
50 grams. So,
51.
31 divided by 2.
did you understand? Okay. In 100 grams, if I am dissolving 62 grams, then it becomes, okay, saturated solution. But now we have taken only 50 grams of water, so only half of it. So did you write it down? Write down. Because you have taken only, see, here they have given 100, na? They have given 100. So the solubility table is for 100 grams of water. Now in the question, what are they asking? See, read the question.
50 grams.
Okay, write down. Write down, make a note of it. At least in the notebook somewhere you write down. Look at the next question. Okay. Which one? Basically, we take it. Makes a saturated solution of potassium chloride in water at 353. Okay, I want you to look at the table of potassium chloride. Where is potassium chloride? The third one. Third one. Correct? Did you see potassium chloride? At what temperature? At 353. That is the last
54.
column. How much is it?
54.
54.
Okay. And leaves the solution to cool. What will she observe as the solution will cool? No need. No need.
Potassium nitrate, chloride.
Potassium chloride. Only potassium chloride. Now we are talking only about potassium chloride. And he has dissolved already 54.
Thus,
Now the question, you see question what? See what is the question? What will she observe as the solution is cooling down?
The solubility.
The crystals of potassium chloride.
Yes.
Yeah.
This will form again. See, the column that they are given under 353 is a supersaturated solution. Isn't it? Because it's at a high temperature. So at high temperatures, when you're allowing it to cool down, the crystals are formed again. Come on, better. For the second one, crystals are formed again. Okay. Look at the question number C.
Ma'am, ammonium chloride 37. Ammonium chloride 37.
293.
Ammonium chloride.
57
37.
is ammonium chloride.
Yes. What about the D part? What is the answer? What will happen to the solubility of a salt when you are increasing the temperature? Change of temperature. They're given a change, so you have to talk both of increase and decrease.
I mean, increase of temperature, the solubility will increase, which result in more amount of salt, dissolving in the water. And when the temperature decreases,
Yeah, the
And
solubility
vice
the
versa.
solubility
Vice
decreases.
versa. Got it? Write it down, Magmay. Write it down in your notebook. As the temperature of the solution increases, as the temperature increases, you can write. As the temperature increases, we are not concentrating. What happens to the solubility? The solubility increases. That's all. Is that okay?
Yes, ma'am, all done. Yes, ma'am, all completed.
Question number 5, 6, all this is over. 5 is okay. Homogeneous, heterogeneous.
We have already done it.
I know, that's why I'm asking you. Virat, you were present when we did homogeneous, heterogeneous.
No, I was.
You were absent. One day I know you were also absent for your school exam or something like that. So,
Homogeneous.
now you should do well for your exam now coming up. Boys,
Now I want to
Sunday.
Ma'am, there is real exams from like school exams from.
Actually, this will just help you to do better, no? This is an additional practice that you're
नहीं
getting.
मैम डर लगता है मुझे लगता है 9th
Yes, why wait to fight? No, no, that, come on. See now, 7th question. Go to 7th question. Read the question.
Which of the following?
Which of the following materials fall in category of
Pure.
pure
Ice.
ice.
Okay,
Ice.
first thing about what is a pure substance. It is element and compound.
Ma'am, ice is pure. Air is
Take away all the mixtures. All mixtures you take away.
Air is impure.
Here is
Impure.
no, it is not impure. It is a mixture.
मैम
एयर मतलब ऑक्सीजन बोलोगे क्या
Air is what? It is a
Air,
mixture.
nitrogen, sulfide.
बहुत सारे
It's a
ma'am
mixture.
कैल्शियम
ma'am ice, iron, calcium oxide, mercury, that's it.
हाँ मेरी
ACEF.
हाँ AC
ACEF.
D also.
हाँ
Hydrochloric
ACD
acid. Hydrochloric acid. What is hydrochloric acid? HCl. HCl. Yes, it's a compound. Just like sulfuric acid. What is sulfuric acid? It is H2SO4. Okay. So this is hydrochloric acid. Make a note of it. You will have to learn formulas now very shortly.
For
periodic
Hydrochloric acid.
Hydrochloric acid. Because this is what we are going to do in our next lesson. The rest of it is all they're just asking about, which are the following. Go to question number 11.
मैम 8
These are simple ones. These are simple. Using the 11, come to 11.
which of the following is so single effect?
मैम rest of the file
First you think, first what if you think? I'll ask you one about.
Classify the following changes.
11th one. Question number 11.
Following changes.
Ma'am,
Classify the following
Wait.
मैम हो गया ना
क्या क्या
A B G D G E
changes.
I got ready-made answers.
E का
Ah.
ma'am Ma'am,
ATGE, ma'am, ATGE.
ma'am is wrong.
Growth of a plant. Growth is what?
Chemical. Ma'am, बड़ा हो रहा है ma'am. It's the same like the writing of fruit basically.
Agreed, everybody? It's a chemical change. Yes.
Ma'am, D resting of iron.
Yes, it's also.
Chemical.
Ma'am, T, sorry, E.
C.
Ma'am, is skip D.
Okay, what is
D
C?
नहीं है ma'am.
Okay,
C,
C is
C,
not.
C.
C is only mixture.
Physical.
Yes, ma'am.
M
Cooking
physical.
of food.
Ma'am, it's a chemical change.
change.
कैसे ma'am? नहीं ma'am.
Why do you feel it is a chemical change?
And which is
Ma'am,
chemical.
taste changes.
Uh,
Ma'am, odor changes.
Cooking of food is definitely yes, because you are not only chopping food, but you're probably adding
Ah,
salt, sugar,
chemical.
so maybe.
हाँ, कैसे? मतलब मैं Bluetooth से मैंने कितना आंसर दिया.
Okay, like
Ma'am, chemical.
freezing,
No, physical.
Physical.
burning.
Chemical.
Burning is a
Physical and
burning of
chemical,
kind
both.
is definitely a chemical change. Okay, only melting of ice. Suppose they say melting of wax, then you can say chemical change. But if they say burning, then definitely it's a chemical.
Because flavors included.
Okay, question number 10.
Classify the following into elements, compounds, and
Why don't you make a table now? Quickly, come on. Elements, compounds, and mixtures. Question number 10.
Ma'am, क्या
Solution है.
Elements, compounds, and mixtures.
Elements compound.
Whole element.
Both of you come on. I've asked you to. Now everybody will do this.
Yes, ma'am, we are doing it.
Maybe come on quickly. Make a table.
Compounding methane, element, carbon dioxide, compound, blood. Yes, ma'am, done.
हो गया ma'am.
No, in your notebooks. Quickly.
Ma'am, what is silicon?
A compound.
Silicon is an element. Silicon. Silicon.
Ma'am, what does soil consist of?
Different substances.
Humus and everything.
It's a mixture.
And sodium is also element.
It is a scale.
So, sodium.
Go through your volume, okay? Right? Plenty of examples given there.
Ma'am, अगर मैं सिर्फ ABC मतलब
No, please write numbers. Write numbers, so it's easy for you to remember. Okay, you can add on to that list also later on. What about soap?
Mixture.
Mixture.
You have got color, perfume added, fats added.
Ma'am, calcium carbonate is like a big element, right?
Compound. Calcium carbonate. See here. Calcium carbonate. Write down the formula for calcium carbonate.
CaCO.
CO3. CaCO3.
ma'am blood mixture होगा.
Yes. Plasma, WBC, RBC, everything is there. What's the formula for carbon dioxide?
CO2.
CO2.
Methane, anybody remembers? Anybody knows methane?
SO2.
No. Methane is CH4. And CH4 is methane.
Well.
Write it down.
Ma'am, methane is अच्छा हाँ.
Ma'am,
CH4.
whole
Silver is CaCO2.
Coal is only carbon.
Silver is SO2.
whole would be element.
I'm done.
मैम मेरा भी होने वाला है मैम पहले सबका सुनेंगे फिर इसका
Ma'am, completed.
First you tell me only the elements.
Sodium, silver, silicon, gold.
What about
इसमें मैम सोडियम सिलिकॉन टिन सिलिकॉन मीथेन कार्बन डाइऑक्साइड
मीथेन नहीं, कार्बन डाइऑक्साइड भी नहीं।
मीथेन
कार्बन डाइऑक्साइड का कंपाउंड है।
हाँ
हाय।
Theme you forgot. Right now.
Yes, ma'am. Ma'am, then compound the sugar solution, calcium carbonate.
Sugar solution.
Yeah.
So that comes as a mixture. Sugar solution. Okay. So then what did you write?
soap.
Soap and
नहीं, look जाओ. The
Soap is
compounds
CO2.
में CO2 and methane. And then in mixture, soil, air, soap, blood, sugar solution.
soil, air,
Blood, sugar solution.
Soil has soap is in compound.
And soap is mixture, right?
mixture of many substances.
And then what is
All soaps are not the
CaCO3?
same. You can understand. All soaps are so
And
different.
what is CaCO3?
CaCO3 is calcium
Compound में क्या
carbonate.
है?
Ah, okay.
Compound.
कंपाउंड में मैम मेरे को
First,
Okay, I'll tell you. Just check whether your answers are correct. Sodium element, soil,
mixture,
sugar solution,
mixture,
silver,
element,
calcium carbonate,
compound,
tin,
element
element, silicon,
element
element, coal,
element
air,
Mixture.
soap,
Mixture.
methane,
compound
compound. What's the formula for methane?
CH4.
CH4. Okay. Carbon dioxide.
And soap is compound.
Compound. It's a mixture of many compounds. Okay, there are many substances. Fatty acids are there. Perfume is there. Okay,
in element.
and then blood, of course, is
Mixture.
Then.
तो मैम तीन ही कंपाउंड
What?
नहीं मतलब क्या
Are you okay now?
Yes, ma'am.
Okay. Go on to the next chapter. Now, of course, there's not much time. I'm just showing, giving you a small introduction. Chapter number 3. Yes, now going to talk a little more about atoms and molecules.
Atoms and molecules. Atoms and molecules.
Firstly,
एक
please
सेकंड
concentrate now.
मैम वन सेकंड मैम
If you look at the
मैम एक सेकंड
pages, I just want you to
Second
look
come
at the
again.
pages. What is an atom? Okay, atomic mass. We are talking about molecules of elements. What is a molecule? How we are going to write
इसे ना ये
chemical
चैप्टर बताओ
formula?
ना
See here, page number 32. That is where you require a lot of practice.
मैम ये चैप्टर बताओ क्या बोलूं
This one, the symbols for some element.
मैं कह रहा हूँ ये
Chapter number 2 is over.
Acha, ionic compound.
Okay, look at page number 32, 33, 34.
Yes, ma'am.
Here you require a lot of practice and you have to learn up. Okay. And also how to calculate atomic mass, molecular mass, exercises. Okay, so we require a lot of.
Ma'am, in school we are not completed this first chapter also.
What's this for
No,
Tananya?
ma'am, we
First
are
completed,
doing
second started.
and we are doing the exercise questions.
First one.
Yes.
Okay.
Ma'am, it is over.
What is
Second
over?
chapter.
Our exams are also over.
Now
First chapter
page
is-
number 31. Just look at page number 31.
yes ma'am
Okay. There's a small table 3.3.
Ma'am, in volume.
Non-metals. Okay. Are you familiar with argon, helium,
Yes,
oxygen?
ma'am.
Okay. Do you know the symbols of a few of them?
yes ma'am
क्या
Come
बता?
to page number 29.
Argon का symbol क्या है?
Look at page 29. Are you familiar with this table? See this table?
We are definitely like eight, but
20.
ma'am, here to
Up to 20,
yes,
Up to
but we are
20, you know?
not it.
you better revise because we are going to start now.
just the over
कोबाल्ट का CO.
And
हाँ,
which
देखो हमारा
balloon
इससे
which
पूछ रहा
stage?
हूँ
This one.
CO.
Balancing.
Not balancing, not balancing. I'm talking about symbols of some element.
That's a that one.
कारण क्या?
Aluminium.
C1.
Aluminium is Al.
Yes. Okay. Okay, now listen up. When we write
Iodine.
when I talk nobody else will talk. How do we show elements? In the earlier days, people used to show it in the form of certain symbols. Okay, put a dot, draw a triangle, put a stick, put an arrow. But now, of course, there's such a lot of advancement that we have started using elements in the form of certain symbols. Okay, so next class we are going to discuss a lot about what is meant by an atom, what is a molecule, how do we write it down, etc. etc. So I'll see you next Wednesday and do your test when two chapters, huh? 2 chapters. Learn up all the definitions.
Ma'am, the symbols.
40 30. And it is 30 marks, na?
NaCl and all.
30 marks.
Whatever is there in chapter number 1 and 2.
Rain, Punai.
Yeah.
Thank you.